To fly to the limits of space is still pondered upon by many. To fly a scientific experiment on board the Mars 1 lander in 2018 may be a dream for some, but for Leeward Community College student Jonna Ocampo, this dream may become a reality. Jonna's proposal encompasses the work from a biomedical summer internship, a proposal that was submitted by her to the Mars 1 University competition. It was accepted as one of 35 entries from around the world. Only 3 of the 35 were submitted by women. A project page was granted to her by Mars 1. Ab initio, to Mars 1 proposal was done for the purpose of scientific discovery, increasing antibiotic effectiveness in space for astronauts, and for developing potential new treatments on Earth. This is to be achieved through synthesizing a series of compounds called chalcones. These derivatives use the constant of a chloro with its location on every position of the aromatic ring. Determination of the antimicrobial efficacy in space in regard to Pseudomonas aeruginosa, Staphylococcus aureus, and Escherichia coli will be performed through indirect methods. Observations to the change in the environment around these synthesized molecules will be studied. The background of the chalcone and its formation is the result of the aldol condensation product. The starting materials are an acetophenone, a benzaldehyde, and a base catalyst of sodium hydroxide. Research studies and literature show chalcones to have antimicrobial activity. Its importance is prime because of its list of biological activity: antibacterial, antifungal, antioxidant, anti-inflammatory, and anti-tumor potential. As the past and the future commingle, moving this experiment forward into space has endless possibilities. In evolving from ground-based studies, the chemistry was dependent upon the synthesis of a compound. The reactants going to completion to form the desired product was crucial. It is the path that a mechanism follows for a reaction that determines its final product. Its purity is validated by its melting point, percent yields, infrared spectroscopy, and nuclear magnetic resonance. As a result, preliminary ground-based results were successful. The hypothesis is relevant to zero gravity. A chalcone in the presence of an alpha-beta unsaturated functional group will be responsible for having antimicrobial activity against specific bacteria that plague us on Earth. Pseudomonas aeruginosa, Staphylococcus aureus, and E. coli are 3 of the bacteria. In ground-based studies, biological assays using Mueller-Hinton-Agar as the standard media was successful in producing measurable zones of inhibition. Zones of inhibition translates to fighting off bacteria. Regarding the Mars 1 competition, the hypothesis would be proven by measuring the indirect effects through the use of clinostats or rotating wall vessels. This will allow one to observe the change in environment around the synthesized samples, and mimic the effects of zero gravity in space. The reason for using the clinostat, or a rotating wall vessels, is that the scientific literature shows in conducting a biological assay similar to this experiment would not yield successful results in reduced gravity. This is due to the compound's small particle size and available quantity. Once proven successful, these ground-based studies will advance to testing in a microgravity environment. A parabolic flight will be required for noting the reduced gravity duration. Other modes of testing may be explored using the European Modular Cultivation System to ensure the biological experiments are conducted using controlled conditions. Its system is ideal because it uses 2 centrifuges. It will allow for observation to the change in environment around the chalcones in the microgravity prior to the Mars 1 2018 flight. This will confirm the hypothesis for this university scientific experiment. Please show your support and log on to the Mars 1 website and vote by rating Jonna's project. It is your rating that can see this experiment shoot for the skies and, most importantly, fly to Mars. Please vote by creating a login name on the Mars 1 website, located under the community link in the top right-hand corner of their website. This site is located at https://synthesis-of-derivatives-. And that is the end of the recording.